Hello everyone, welcome back to another episode of ArcGIS. I think now we can do some spatial operations in ArcMap or ArcGIS. In this video I have prepared another project for you. So now we are going to solve this. Here we can see there are two shape files here. One for RCC word boundary, another one. Here we can see some another field. So the first question is prepare RCC boundary using spatial data of odd boundaries. Okay, here you can see if you go into the attribute tables of RCC, there are so much field here. So we are going to prepare a RCC odd boundary here. So in this case we are going to dissolve these things first thing, and then going to put the input picture here, and then going to set output name.
Yes.
Which is RCC word boundary dissolve. Okay, save these things and then pressing OK. So now if we uncheck these things and uncheck these things, here we can see the RCC word boundary is in a single shape. So that is what the first question asks for, prepare RCC boundary using spatial data of word boundaries. And our next question is taking 500-meter buffer as the standard service area of primary. So if we go into ArcMap once again and then going to education facilities, here we can see the single dots are called primary schools. Okay, so the first question is to take 500 meters buffer as the standard primary school service. In this case, now we're going to geofencing, then going to buffer, and here we need to put the input class for the educational facilities, and now we will put an output feature class here. Okay, and the unit is 500 meters. Okay, and pressing it. Our primary operation is done. These individual circles are the buffer of this primary schools. Then our next operation is to calculate the percentage of only served area, overserved area and underserved area within the RCC area. So here we can see this area are called unserved area and this individual area are called served area, and here you can see there are some areas which are overserved. So now we are going to find out the percentage of unserved, served and overserved area. In this case we are going to geofencing first and then going to intersect and find out the overserved area by intersecting this. So we are going to drag these things and put it into input features and then put an output feature class. Okay, intersect, save it and then pressing it OK. So now here you can see the overserved area is now founded. Now we are going to dissolve this intersect and make it in a single shape. Okay, so going to geofencing, then going to dissolve and drag this to input feature class and put an output feature. Okay, and then pressing it OK. So now here you can see the intersect are in a single shape. Now we have to do another dissolve for this educational facilities buffer. Okay, so we are going to geofencing, then going to dissolve and put this to input feature class, put the name output feature class to 500-meter buffer dissolve. Okay, save and then press it OK. So we are going to uncheck everything. Here you can see this area is for served area, and if we check this thing, this area is for overserved area. So we are going to make this all in a single shape file. So in this case we need to go to Arc toolbox, then going to analysis tool and then going to overlay, and here we will select identity. We are going to put the 500-meter buffer dissolve to the input feature class and then 500-meter buffer intersect dissolve to the identity features. We need to put a name first. put identity 1. So then pressing it, okay, uncheck these things, and then if you look at this shapefile, here you can see these two features are in a single shapefile. If we are going to the properties and then symbology, then categories, and then add all values, and if you press apply, and here you can see this area are for served area and this area are for overserved area. So we are going to identity once again with the RCC word boundary resolve. So in this case we are going to our toolbox once again, then going to identity, and then put the RCC word boundary resolve to the input features, and then identity to the identity feature class. Okay, so put another output feature name which is identity 2, and then save, and okay. So now if we uncheck the identity 1, yes, identity 1, here you will see the served, overserved and unserved area in a single layer. So if you going to the properties and then going to categories and put FID identity 1 and add all values, and then apply and press it okay. So here you can see the served, overserved and unserved area in a single shapefile. So if you going to the attribute tables of this shapefile, there are 3 polygons here. So now we are going to add a field for the status. Okay, and this will be in text. Set this thing to text. This -1 is called the unserved area. So we are going to select this row, going to field calculator, select a name unserved. Okay, now in unserved area, and if you look at this, 0 means the served area. So selecting, then going to field calculator once again, and then put the name for served, pressing it okay, then select similar field calculator, and then overserved, pressing it okay. You can see we have separated this served, overserved and unserved area. Okay, now we are going to add another field to calculate the area, double, and okay. So if you select the whole column, then going to calculate geometry, the unit is square kilometer, and then pressing it okay. Now the area of this served, overserved and unserved area is bounded. Now our next question is to calculate the percentage of served area, overserved area and underserved area within the RCC area against each word with reference to the total RCC area. Our first question was to find out the only served area, but now in this case we need to find out it against the each word with reference to the total RCC area. So in this case we need to intersect our identity 2 to the RCC word boundary. To intersect these things, going to georeferencing, then intersect, and then the input features to the identity 2 RCC word boundary. Here put output feature class name identity 2 intersect, and save these things okay. So now if we going to the attribute tables, here you can see there are some such of data here. In this case we need to update our areas which we found out in our previous question. So selecting the whole area and then going to calculate geometry once again, and then make it to square kilometer, and then pressing it okay. So here you can see the area is now updated. So we need to update the percentage also. So now we are going to statistics and then copy the sum, and then going to select the whole column of percentage, field calculator, and then similarly put the equations area and then divided by this total sum into 100. Press the Okay, so here you can see the percentage now also updated. So we are going to do the operations in Excel. Select all, copy selected, and then going to Microsoft Excel. Here I have prepared an Excel file, so we're going to paste these things. So now we are going to prepare the pivot table. Going to insert and then existing sheet, and our target layer is here. We are going to put the percentage to the values. RCC word boundaries, we are going to find the RCC word area. To the rows we need another things, which is status. Area percentage of served, underserved and overserved area within the RCC area against each word boundaries is now founded in this pivot table. Here you can see, and the grand total is 100%. This question is now solved. Then our next question is to calculate the percentage of served area, overserved area and underserved area within the RCC against each word with reference to the odd area. Difference is between the total RCC area and between word area. So in this case we are going to open this attribute tables once again, unselect everything. So in this case we are going to add another field for the updated percentage. We are going to put the name PERCENTH. Okay, so then put it to double and then pressing it. Okay, so maybe the name is invalid, so no issue. We are going to select the whole column, then going to fill calculator and then change the equations. In our previous question you saw the area is divided by the sum of the total RCC area, but in this case we are going to divide the area by the odd area. Here you can see the word area 1 is called the odd area. So this is the equations. Okay, put the okay, and here you can see now the percentage is now updated. Okay, so we are going to select everything similarly, then copy everything, minimizing, then going to Excel once again, create another sheet, then paste it here and then prepare another pivot table. Okay, so our existing sheet, target here, put the percentage on to the values and similarly word ID to the rows and the status is to the column. So now here you can see the percentage of overserved, served and underserved with reference to the each odd area is now founded. Here you can see the difference between the previous question was the total grand total percentage or 100%, but in this case which was with reference to the each word, that's why the grand total is now 2999.99%. So our question 3 is now solved. Now our next question is to calculate the percentage of population for underserved area, overserved area and unserved area within the RCC area. So if we going to arc map once again and then going to the attribute table, here you can see there are some field for the population for 19 and 91, 2001, 2030 and 2031 and 2041, and another one is for 2020, and there are some densities also. In this case I will find out another density for 2020 because I don't know the unit of this densities here. So we are going to add another field for density, DEN_20. Okay, so density couldn't be in float or double, so we are going to select the input to the short integer. Okay, press it OK, and then going to select the whole column, then going to fill calculator, then yes, and then put the equations, populations of 2020 divided by the odd area, which is area_1. Okay, and press it OK, and here you can see the density of 2000 is now founded. Now we are going to find out the population status with reference to the served, overserved and unserved area. So in this case we are going to add another field for population, and in this case this is similarly short integer, and then going to select the whole column and then going to fill calculator, yes, and then put an equations to find out the population status with reference to the served, overserved and unserved area. So in this case we are going to density 21 and into area, yes, okay. Here we can see population status with reference to the served, overserved and unserved area is now founded. And the last thing is to find out percentage. So we are going to add another field, population percentage, short integer, and then press it OK. So in this case we need to know the total sum. Okay, so we are going to copy the sum, Ctrl C, and then going to select the whole column and then field calculator once again, then put the equations to population status divided by the sum, closing the bracket, into 100 and then press it OK. The population percentage with reference to the served, overserved and unserved area is now founded. So we are going to copy everything for selecting everything, then going to copy selected, minimize these things, and then going to Microsoft Excel, create another sheet and then paste everything here, insert a pivot tables here, existing sheet, okay. In this case our question was to calculate the percentage of populations for underserved, overserved and unserved area within the RCC areas. Need two things, population percentage to the values and status to the rows. Here you can see percentage of populations of overserved, served and unserved area is now founded. Our next question is to calculate the percentage of population of for underserved, overserved and unserved area against the each odd area with reference to the total RCC area. Similarly, the B number question with reference to the RCC areas. So in this case, we don't need to go to the ArcMap once again. Here we will just change two things, status to the column and similarly word ID to the rows. And here you can see the percentage of populations of overserved, unserved and served area within the total RCC area is now founded, and each odd area is now showing here. Okay, so our question number E is now solved. Another question is to calculate the percentage of population for underserved, overserved and unserved area against each odd area reference to the odd area. Similarly, the question number C. So in this case we will just put another equations in the attribute tables, clear everything, then going to put another field,
pop percentage 2 and similarly short integer and then press it OK. Then selecting the whole column and going to the field calculator once again and then put the equations. So here the equation is first bracket and then population status is divided by population of 2020, closing the bracket, into 100 and I'm pressing it OK. And here you can see the population percentage is now founded. And then similarly we are going to select the whole data, then copy everything, minimizing and then going to the Excel sheet once again, then paste everything. And then we will make another pivot table here, everything similar, status to the column, odd ID to the rows and updated population percentage to the values. And here you can see our question is now solved.
Okay, our last question. Calculate the percentage of population within overserved area based on the ability of service like double served, triple served and the like. Okay, so in this case we need to understand the question first. Calculate the percentage of population of overserved area, which means if we're going to the ArcMap once again, and here we can see, going to uncheck everything, just simply check the intersect area and then in the buffer. So in this case our question is to find out the percentage of population of overserved area. So here you can see the these single dots are called primary schools, but this area is got the facilities of this primary school, this primary school, this primary school, and this primary school. So our question is to find out the percentage of population of this overserved area. Okay, so now I think you understand the question. So in this case we need to do some operations. Okay, let's begin. Zoom to layer, uncheck everything, and just we need two things, one for RCC odd boundary dissolve and one for 500-meter intercept. Okay, so don't be confused, one is 500-meter intercept and another one is RCC one boundary dissolve. So we are going to identify these things. So for this case we are going to do our toolbox and then open the identity tool once again, and then drag the RCC word boundary dissolve to the input class and then 500-meter intercept to the identity class. Okay, and then put another name, identity 3. Okay, so then the RCC word boundary and 500-meter buffer intercept are now in a single shape file. Okay, so uncheck everything and then only these two things. If we going to the attribute tables, so this is the attribute tables of our new identity. So in this case we will only work with the overserviced area, we don't need to work with the unserved area. Okay, so if we go into the attribute table, if you select the FID 0, which is selected the unserviced area, so we will just simply remove this unserved area. To unserve this area we can unserve these things by going to the properties and then going to definition query. We are going to build a query which is FID is not equal to 0. So if you put the equations and build the query is if FID is not equal to 0 and then press it OK and then apply and OK. Now you can see the unserviced area is now removed. If you going to the attribute tables, here you can see the unserved area is now removed. Okay, now we are going to find out the area of this overserviced area. So we are going to put a name, area identity. Okay, in this case we are going to put it to short integer and then press it OK. Okay, so our field is now created. Selecting the whole field, then simply calculate the geometry, set the units to square meter. Okay, so here you can see our area of this overserved area is now 100. Here you can see there are some areas have no values, 0 0 0 0. So we don't need to work with these 0 values or this kind of smaller than 10 values. So we will simply just remove this kind of fields here. So in this case we are going to build another query, going to properties and then query builder. We will also use our previous query, put these things and then put an area is greater than or equal 10 and then press it OK and then apply these things and then OK. So if we go into the attribute tables now, 0 values or the less than the 10 values are now removed, only the large values and which we will work for is now available. And if you look at this attribute tables, you can see this area is similarly got the facilities for the primary school of overserved area. So we will count this kind of overserved area in Microsoft Excel. So we are going to select everything similarly and then going to copy, selected and then going to Microsoft Excel and open another sheet and then paste everything. Yes, everything okay, and then going to insert a pivot table here. Okay, so in this case we will just put two things, which is area to the rows and area to the values. Now we will just go in here and then change the sum to count, and here you can see 14 areas got the facilities of 10 meters of overservice area and 4 areas got the facilities for 11 meter service areas. This is how we actually count the service area. Now we are going to select this column, simply Control Shift and right arrow and then down arrow. Okay, Control C and then going to paste it in a new worksheet we are going to paste it in values. We have just simply remove this grand total values. Now select everything and then put a name database. Okay, simply enter, and then save these things to your PC or hard drive, and then going to ArcMap once again. Now we will join this database to this attribute tables, but there are so many data here, we don't need to work with this kind of data, so we will just simply dissolve these things with reference to the area identity. So we are going to dissolve this, going to georeferencing and then going to dissolve, put the input feature, output feature class name, and we are going to dissolve it based on the area identity. Okay, so we are going to check these things and then press it. Okay, and simply uncheck the previous one and going to the attribute tables. Here you can see only two things here, on each shape files and on each area identity. Now we will just join the database to this attribute tables. To join these things, we're going there and then join and relate and then join. We will join with the area identity, so we select the area identity. Here we will just connect the Excel file here and we select the database, and our key field is row levels, that's why we just simply select the row levels and then okay. Now the two tables are now joined. And now one last thing we will do is to going to the properties and then going to symbology, going to categories and select the count of area and add all values. If we apply these things, and here you can see, press it okay. Now this is classified, and then we will just enable the labels, but it is showing different, so that's why we need to go to the labels once again. It will take some time. Yes, here we will just simply change the label fields to count of area identity and press it apply and then okay. Here you will see the service area of 2, 3 and 4 is now saying. If you press info icon, here you will see this area is covered for surface area, and this is how we actually count the overserved area. And our question is to find out the population percentage. So if you want to find out the population percentage, one last thing to do is intersect the populations or RCC word boundary areas to these shape files, and then going to find out the population status and then going to find out the population percentage. And similarly, if you going to copy this whole things and paste it to the Microsoft Excel, and then similarly you can find out it by the pivot tables. So this is how we actually do some another spatial operations in ArcGIS. So that's all for today. Thank you everyone.